All right, here we go for video number 2 for today. Answers to review for quiz 13. We've got 10 problems on this one, so this one shouldn't take as long as the last one, hopefully. All right, inside function on number 1 is x cubed plus 5. So I've got it set up over here already. We need to take the derivative. So my derivative is 3x squared dx. I've got the x squared and the dx. I don't have the 3, so I need to move the 3. So we're looking at 1/3 and u to the 6th. Integrate. So we get u to the 7th times 1/7 times the 1/3 that's out in front. This is a definite or indefinite integral, so make sure you don't forget the plus c. I have 1/21, and make sure we put x cubed plus 5 back inside. And that's all there is to number 1. Pretty simple stuff. All right, number 2. Number 2 is a definite integral, so we will not need the plus c, but we will need to change our limits. So inside function is x cubed plus 1, derivative 3x squared dx. I've got the x squared dx. I do not have the 3. Alright, so the 1/3 needs to come out here. We have u to the 1/2 inside, and we need to change our limits. So we have 0 and 2. Plug in 0, gives me 1. Plug in 2. 2 cubed is 8. 8 plus 1 gives me 9. So 1/3 times, so I get u to the 3/2 times 2/3. We're going from 1 to 9. Put these together, which gives me 2/9. Plug in the 9. Plug in the 1. Do the bottom first. Square root of 9 is 3. 3 cubed is 27. And again, we know that 1 to any power is 1. So this gives me 26 times 2. And we end up with 52/9 as our answer. Number 3. Number 3, inside function is x squared plus 9. Derivative is 2x dx. I've got the x, I've got the dx. I don't have the 2. So 1/2, and that's going to be 1 over the square root of u du. Now I need to do my limits, 0 and 4. Plug in 0, 9, plug in 4, 16 plus 9, 25. So this is u to the negative 1/2. So u to the negative 1/2 turns into a positive 1/2 times 2. We're going from 9 to 25. So these two out here are going to cancel each other out. So I have 25 minus 9, 5 minus 9, which gives me 3. I feel like we've done that problem before. And that may have been on the other review or on Wednesday's worksheet. All right, next one. 4, inside function, 1 plus x squared. So that's going to be 2x dx. I've got the x and the dx inside. It has a 3. We've got a 2 here, so we need to move the 2. And since it has a 3, we need to move that 3 out with the 1/2. So that means we have 3/2 out front. We're going to have the square root of u du on the inside. And we don't have any limits. So that means when we integrate, we need to put plus c in, and we need to make sure we plug in the 1 plus x squared. All right, so 3/2. So this is 1/2. 1/2 plus 1 gives me 3/2. So that means we need to multiply by 2/3. Don't forget about the plus c. These cancel out. Make sure we plug that back in here. make sure we do the plus c. Okay, that's something, once we start doing these definite integrals and we don't have to substitute back in for u, some of us may forget on these indefinite integrals that we have to put this back in. So don't forget to put this back in. That's a common mistake. All right, 5. Inside function is going to be 5 plus sine. Derivative of 5 is 0. Derivative of sine is cosine. I've got the cosine, I've got the dx, so we're in good shape. I just have 1 over u squared du. So this is the same thing as u to the negative 2. So that's going to be u to the negative 1 times a 1 over negative 1. Don't forget about the plus c. So negative 1 over u plus c. Plug that back in. I get negative 1 over 5 plus sine plus c. All right, 6. Inside function on 6 is going to be x minus 4. Derivative is going to be 1 dx. So we've got square root of u du. But this has an extra x. Since it's got an extra x, that means I need to come back over here and figure out what x is. Add the 4 over, we figure out that x is u plus 4. This has limits, so we need our need our new limits. Bottom limit is 4. 4 minus 4 is 0. Top limit is 8. 8 minus 4 is 4. We need to distribute in here. So u to the 1/2 times u to the 3/2. Hopefully we're getting better at those since we're seeing them quite a bit. And then this is just for u to the 1/2. Integrate. So this is going to be 5/2, 2/5. This is going to be 3/2, 2/3, 0 to 4. So plug in the 4. This is 8/3. Plug in the 4. Minus, when I plug in the 0, that's going to be 0, and that's going to be 0. So 0 plus 0. Again, work the bottom one first. So we want the square root of 4. Square root of 4 is 2. 2 to the 5th, we know is 32. 32 times 2, 64. Square root of 4 is 2. 2 to the 3rd is 8. 8 times 8, 64. I'm happy with that. If you work it out, we end up with 512 over 15. Is what I got. All right, number 7. Inside function on number 7 is 3 minus the square root of x. Derivative of that is going to be, derivative of 3 is 0. Derivative of this, I've got the negative right here, and then we should know derivative of square root is 1 over 2 times the square root. And don't forget about the dx. So in our problem, we've got the square root to match up. We've got the dx to match up. So we need to take care of this negative 1/2. So that means I have a negative 2 du, 1 over the square root of x dx. So the du takes care of this. So that means this needs to go out front. And we get u to the 4th du. It's an indefinite, so we're good. Integrate. Don't forget about the c since it's indefinite, and then make sure we plug this back in. So negative 2 over 5, 3 minus the square root of x to the 5th power plus c. Something else that, and I do this quite a bit, is sometimes I'll forget to make sure I bring that exponent down. Make sure you bring that exponent down. All right, there's 7. Number 8. Inside, this is one we've got to rewrite. Because it looks like inside might be 6x right now, but then we've got cosine squared. We don't know how to integrate cosine squared. So if I have cosine on the bottom, that's the same thing as having secant in the numerator. So I can rewrite this problem as secant squared 6x dx. Once I get there, we're good to go because we know how to integrate secant squared. So that does mean u is going to be 6x. I get 6 dx. I do not have a 6 in the problem, so that means I've got to have the 1/6 out here. I've got to have the dx there. So the 1/6 comes out here. This is an indefinite integral, so we're good to go. So we get secant squared u du. We should know that if we integrate secant squared du, we should have that memorized and know that that's tangent. Don't forget about the plus c, and then don't forget to plug this back in. Alright, so that's number 8. Moving on to number 9, we had one similar to this on Wednesday's assignment, so we should feel pretty comfortable about it on number 9. They tell us what u needs to be. We just have to tell them what it's going to be rewritten as. So u is the square root of x. Derivative of the square root of x we should be getting good at, which is 1/2 times the square root of x dx. I've got the square root of x on the bottom. I do not have the 2, so I need to move the 2 over. So these two swap out. I need to move the 2 to the front, and then we have sine of u on the inside, du. So I know there has to be a 2 here, so we can go ahead and eliminate. We can eliminate a since a has a 1/2, so it's got to be one of these 3. It's probably not going to be the bottom one because they didn't change the limits, so it's got to be b or c as our answer. So all I have to do is figure out my limits. We're going from 1 to 9 there. Plug in 1, square root of 1 is 1. Plug in 9, square root of 9 is 3. So we need a 2 and we need a 1 to the 3. Both of these have 2 and 1 to the 3, but notice they've got an extra u in here. We only want sine of u. So our answer would be C on that one. All right, last problem. It says an object moving along a straight line so that any time t greater than or equal to 0, its velocity is given by v of t. What's the distance traveled by the object from t equals 0 till the first time it stops? Okay, so from t equals 0 to where it stops. So we know we're going to have to integrate from 0, because it says from t equals 0, and then to the first time it stops. So we've got to figure out where does it stop. Okay, and we've got to use the velocity function to figure out where it stops, because we know that velocity equals 0 anytime a particle is stopping. So I need to set velocity equal to 0. I need to set velocity equal to 0 and solve for t, and that tells me where it's going to stop. So I divide by the 2, which gives me that. And now I'm asking myself, when's the first time cosine equals 0? The first time cosine equals 0 is pi over 2. Okay, since there's a 3t in here, we have to set that equal to the pi over 2. Then we divide by 3. And that tells me that the first time this particle stops is at pi over 6. So that means pi over 6 is what I want to put in here up at the top. Alright, so then we put our velocity inside. And now we're ready to work it. Alright, so 3t is my inside function. Derivative would be 3 dt. I've got the dt, I do not have the 3, I've got a 2 instead, so that means I need 1/3 du equals dt. Take the 2 out, take the 1/3 out, cosine u du. I need new limits. Plug in 0, I get 0. Plug in pi over 6. 3 times pi over 6, that's going to reduce to pi over 2. Integrate cosine, which is sine. We're going from 0 to pi over 2. So I have 2/3. I have sine of pi over 2. I have sine of 0. We should all know sine of pi over 2 is 1, and we should all know sine of 0 is 0, so that means we end up with 2/3. So my answer is C. Alright, there are your answers to review for quiz 13. I'll be available in the morning if you need some extra help in the morning. Just give me a heads up, send me a message on Remind, and I will be there. We'll take the quiz tomorrow, which is Friday, and more than likely we'll probably put you in groups of 2 or 3 to work it. So there it is. Enjoy your day off. We'll see you on Friday.